Imagine nothing. Not emptiness, not a dark room, not even the cold vacuum of space. Nothing. Not empty space, but the absence of space itself. No distance, no depth, no direction. Now, try to picture everything, every star, every planet, every galaxy, every law of physics, bursting from it. That's the story we're about to tell. Before there was time, there was nothing. Not a vacuum, not stillness, not even the ticking of a cosmic clock. Just nothing. No atoms, no light, no heat, no dark, no here, no there. No before, no after. This is the hardest thing a human mind can try to grasp. We're creatures of time, of place, of cause and effect. We remember, we plan, we live between the tick and the tock. But before the universe began, there was no tick to begin with, no space to expand into, no rules to obey, no matter to move, no movement to measure. There was no stage, there were no actors, not even a script. And yet, from that great silence came the loudest event in all of existence. But before we get there, we need to sit still in this place, this non-place, this absence. We call it the pre-Big Bang, but that's a lie. Before the Big Bang isn't real. Time itself didn't exist. So what was it? Some call it a singularity, a point of infinite density, a place where all laws of physics break down. Others say the word place is misleading, because nothing can exist without space-time. Some theories whisper of quantum foam, a seething chaos of uncertainty, blips of virtual particles appearing and vanishing in an eternal sea of maybe. A realm where the very fabric of reality is stitched together in fragments, always shifting, always uncertain. But again, we're cheating. These ideas use the language of time, of space, of energy. And in the beginning, there was none of that. Let's put it this way. If the Big Bang were a movie, this moment is the blank screen before the projector rolls. Not the studio, not the theater, the nothing that holds both. Now, if you're starting to feel a little lost, good. That means you're getting close. The truth is, our brains were never built to understand this moment. We evolved to hunt, to gather, to build, to speak. Not to ponder the metaphysical nature of a timeless void. But here we are, a species of curious apes, daring to stare into the abyss before time.
And it's in that abyss, some physicists suggest, that something stirred. Not like wind or motion or noise, but a ripple in probability. In the tiniest scales of the quantum world, far, far beyond the reach of any microscope, fluctuations can occur. Think of it as nature rolling dice, not just once, but forever, in every way, across every possibility. And in one of those infinite rolls, something happened. A shift, a spark, a tremor in the balance, a runaway fluctuation, one that did not return to equilibrium. One that grew, one that would become everything. But even this idea, this quantum ripple, relies on laws of physics we barely understand. Laws that may not have existed until after the universe began. We are quite literally trying to peek behind the curtain from inside the play. And yet, this silence, this absence, this nothing, was not empty of potential. Because in the great paradox of nature, nothingness may not be truly nothing. Just as silence can carry tension. Just as a blank canvas holds infinite possibility, the absence of a universe may have been the condition that made a universe inevitable. Perhaps nothing was pregnant with everything. Perhaps the laws of logic, mathematics, and cause existed in some timeless way, waiting for the right fluctuation. Or perhaps they were born with the universe, part of the explosion itself. We don't know. We may never know. But what matters is this. At the edge of understanding, at the threshold where reason dissolves, there was a moment when everything we now call reality was compressed into something beyond imagination. A singularity. Or not even that. A condition, a boundary, a beginning. And then, in a fraction of a moment too small to measure, the universe was born. But this is only the beginning.
There was no explosion, no flash of flame, no roar echoing through the cosmos. Because in that moment, there was no cosmos to echo through, no air to carry sound, no space to light up. And yet, the universe began. What happened next, what we call time zero, was not an event in time. It created time. One moment, there was nothing. Next, there was everything. A burst, a surge, a singularity unraveling, not just of matter, but of space and time, and the very laws that would go on to govern every star, every cell, every thought. This was not a detonation. This was a becoming. We call it the Big Bang, but even that name is misleading. It wasn't big. There was no outside to compare it to. And it wasn't a bang, because sound needs space and particles. There were none. What was there was a singularity, or so we think, a point, infinitely hot, infinitely dense, infinitely small. Not a thing in space, but space itself, compressed beyond comprehension. And then it changed. In one inconceivably small instant, less than a trillionth of a second, the universe sprang into existence. From smaller than a subatomic particle, it began to expand, not into space, but as space itself. Imagine a balloon inflating, not inside a room, but as the room itself being created. Imagine a grid stretching outward with no edges, no walls, just more of itself unfolding in every direction. This was time zero, the birth of existence as a process. And in that instant, the rules of everything we now know began to whisper into being. Gravity, time, the arrow of cause and effect, the expansion of space, the conservation of energy, the idea of before and after, the temperature, unfathomable, trillions upon trillions of degrees, hot enough to rip apart any structure before it could even form, hot enough to ensure that matter as we know it could not yet exist.
The universe, in this moment, was a blinding soup of pure energy, a chaotic blur of possibility. No particles, no atoms, just raw, radiant power. But within that energy,
Embedded in the chaos were patterns, the blueprints of galaxies, the fingerprints of physics. And one of the most astonishing truths? We can still see this moment, or at least we can see its shadow. Billions of years later, that first instant still echoes around us. The light from that origin still stretches across the cosmos in the form of cosmic background radiation, the afterglow of birth. We'll come back to that. But for now, let's stay in the storm. Time zero wasn't just about expansion. It was about separation. Within that first fraction of a second, the four fundamental forces that govern the universe, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were one. One force. One unity. A cosmic symmetry so perfect that no part of reality yet stood apart. And then, the symmetry broke. We don't know exactly why, but somehow that unity fractured. Gravity broke away, pulling itself into a force that would one day shape stars and collapse them into black holes. Soon after, the strong force and the weak force divided. Then electromagnetism emerged as its own entity. Each step, each shattering, unleashed energy. Each break carved deeper structure into the raw chaos. The universe was undergoing its first phase transitions, cosmic gears shifting, setting the stage for complexity. Imagine water freezing into ice, but with physics itself freezing into form. It's humbling to realize we live in a universe whose very rules had to form before they could be followed. That time itself is not eternal, but had a birth, a beginning, one we can never truly see, only infer, only trace in whispers and shadows. Everything we are, every element in your body, every thought in your mind can trace its lineage back to that moment. That one unimaginable instant, the moment when reality woke up. Time zero. The bang, without a sound.
We have arrived at the very edge of knowable reality. The Planck time. 10 minus 4 third seconds after the beginning. A number so small, if you tried to count it, 1 second would contain more than 10 million trillion of them. This is the first frame of the universe's film reel, and the moment beyond which our physics breaks. In this instant, the universe is still smaller than a proton. Its temperature, 100 million trillion degrees. Its density, beyond anything the human mind can hold. This is not a place, this is not a time. This is a fireball of becoming. Everything that will ever be, every galaxy, black hole, planet, creature, memory, is locked inside this chaos. There is no up, no down, no direction, no past, only a single violent now. And in this fireball, reality is not stable. Space is still tangled with time. Forces are still one. And quantum gravity, a theory we do not yet possess, rules the chaos. This is the quantum gravity era. We cannot see it, we cannot simulate it, but we can imagine. In this moment, the entire universe is governed by a single, unified force, a theory of everything, playing out in pure form. Some believe it's superstring theory, tiny vibrating strings, each frequency a different particle, a different law. Others invoke loop quantum gravity, where space itself is made of tiny loops woven like a cosmic fabric. But all we know for sure is this: our equations collapse here. The theories that govern atoms and stars, the familiar quantum mechanics and general relativity, turn into static. They can't agree. They can't coexist. At 10⁻⁴ third seconds, nature shrugs at our science.
This moment is like the birth of language. Before grammar,
before syntax. Just raw sound, raw energy, raw meaning. The fireball pulses outward, expanding faster than light itself, not through space, but as space. And still the forces of nature remain entwined. Gravity is not yet weak, it is as strong as the nuclear force shaping everything, bending time into strange geometries. It is possible that miniature black holes blink into existence, tiny, unstable, gone in an instant. Some theories suggest they may have formed and evaporated, leaving behind ripples, scars in space-time. And those ripples, they might still echo today as gravitational waves imprinted in the fabric of the universe. But we can't test it. Not yet. We are staring into a time when all certainty is theory, a horizon we cannot cross. And that's what makes this moment sacred, because it represents the limit of human knowledge. The Planck time is not just a number, it is a cosmic wall, a veil. And behind it, possibility, terror, wonder, the most fundamental truth of our reality. This is the universe at its rawest, unfiltered by scale, unshaped by structure, a fireball of potential. No stars, no particles, just energy exploding into newness. But the chaos cannot last, not forever. The fireball begins to cool, only slightly, but enough. And that cooling sets off a chain reaction, a cascade of transformations. In moments, forces will separate, the universe will expand, laws will emerge. But this moment right here, at 10 to minus to 94 thirds seconds, is the pivot point. It is not just the birth of space and time, it is the birth of structure. The geometry of space-time is beginning to stretch. The tiniest differences, imperceptible at first, are about to be amplified. Quantum fluctuations, little ripples in the fireball, will seed the galaxies. The randomness inside this inferno will someday become stars, solar systems, planets, you. In that way, you are not separate from this fireball. You are descended from it, built from its cooling embers, a product of the briefest instant imaginable. And then, just as suddenly as it began, this era ends. 10 to minus to 94 thirds seconds pass, a flicker, a flash, and the next chapter begins, one of inflation, of runaway expansion, of a cosmos about to explode outward at speeds beyond imagination. But the moment we leave behind, the fireball of creation, will remain the greatest mystery in science. It is the one place all paths lead to.
In a span of time so small the human brain can barely conceive it, the universe grew. Not slowly, not steadily, but in a surge. A runaway expansion, a cosmic inflation unlike anything before or since. From a point smaller than a proton to a size larger than a galaxy. In less time than it takes for light to cross a single atom. 10 to the minus 366 seconds. The universe is a glowing dot. By 10 to the minus 362 seconds, it's a sprawling immensity. It didn't just grow, it ballooned. It inflated. This is the inflationary epoch. And it defies everything we think we know about motion, scale, and speed. You've heard the rule, nothing can move faster than light. But inflation doesn't move through space. Inflation is space, expanding itself. Space doesn't follow the speed limit. It writes the rules. In less than a trillionth of a second, distances between points grow by a factor of 10 or 660 seconds or more. To grasp that number, imagine a marble growing to the size of the observable universe instantly. The scale is impossible, and yet it must have happened. Why? Because without inflation, the universe we see today makes no sense. Everything we observe, the flatness of space, the evenness of temperature across billions of light years, the structure of the cosmos, it all requires a mechanism to stretch the young universe so fast it smooths out every wrinkle. Inflation is that mechanism, a kind of cosmic ironing. The early fireball was chaotic. Tiny ripples of quantum randomness flickered in and out of existence. But when space itself inflated, those tiny fluctuations were stretched, frozen into place, seeds of future galaxies. The cosmos, it turns out, is not random. It's imprinted. With ancient noise, quantum whispers made colossal, a map of destiny etched into the fabric of space by a moment that lasted less than a blink. But what triggered this inflation? Here science walks a knife's edge between theory and imagination. One leading idea suggests a field, the inflaton field, a kind of energy woven into the vacuum of space. When the universe was born, this field was trapped in a high-energy state, unstable, poised to collapse. And when it did, it released a flood of energy, not an explosion outward, but a stretching inward of everything, everywhere. Imagine a rubber sheet stretched tighter and tighter, then, in a flash, it lets go. That's inflation. And what came with it was order.
In the universe, a new kind of drama begins to unfold. The violence of inflation has passed. The universe is no longer expanding faster than light. It's expanding more calmly now. But it's still scorching, still dense, still teeming with energy. The temperature, 100,000 trillion degrees. The pressure, indescribable. But within this storm, something miraculous begins to happen. From pure energy, particles are born. The universe throws a party at the smallest imaginable scale, a particle party. And everything shows up. Quarks and antiquarks, electrons and positrons, neutrinos and antineutrinos, gluons, photons, bosons. The entire cast of the Standard Model makes their debut. This is the primordial soup, a furious churn of particles popping into and out of existence, colliding, annihilating, recreating. It's not calm, it's not quiet, it's a battlefield. For every particle, its twin, a mirror image, an antiparticle. Identical in mass, opposite in charge, equal in presence. Every time they touch, they destroy each other in a flash of light. This is the defining tension of the early universe. Matter versus antimatter, a perfect symmetry, but a fragile one. Because in a perfect universe, every bit of matter would be canceled out by its antimatter twin. And the aftermath? Only light, only radiation. No atoms, no stars, no you. But something breaks the symmetry. We don't know why. We don't know how. But somehow, for every billion pairs of particles and antiparticles, there was one extra particle of matter. Just one. One lonely quark without a matching antiquark. One solitary electron without a positron to cancel it. A tiny imbalance. One in a billion. But in a universe of such unimaginable numbers, that was enough. Enough to tip the scales. Enough to survive the annihilation. As matter and antimatter collide in a blaze of mutual destruction, these survivors, these stray particles, remain. And they become everything. They cool, they link, they form protons, neutrons, electrons. The building blocks of atoms, of chemistry, of biology, of thought. You are not made from just any matter. You are made from what was left behind, the miraculous remainder of a titanic cosmic rivalry. But that's only part of the story. As these survivors settle, other forces begin to shape their future. The strong nuclear force glues quarks together into protons and neutrons. The electromagnetic force pulls charged particles into interaction. The weak nuclear force mediates decay, shaping what lives and what fades. And the particles start forming families,
triplets of quarks inside protons and neutrons, swirling orbits of electrons, a chaotic yet emergent order. Even now, the universe is still too hot for atoms to form. Nuclei cannot yet catch and hold electrons. But the ingredients are here. The fundamentals are in place. They are waiting for the right temperature, for the right moment, to come together as the first elements. But first, we must deal with time. Because all of this cosmic alchemy is still happening in less than a millionth of a second. Think about that. From raw, undefined energy to a structured cast of subatomic players in the blink of a blink of a blink. As space expands, it cools, and that cooling slows the energy storms. The particle party begins to quiet. The chaos settles. The photon bath floods the universe. This radiation, the cosmic firelight of annihilated matter, is still echoing through the universe today. Billions of years later, we can detect it. It is the cosmic microwave background. But in this moment, it is not soft. It is blinding. It is everything. It fills the universe with a white-hot brilliance we cannot imagine. A light that holds memory. A light that saw the first quarks form the first protons. A light that will survive long after the last star dies. Now, we are approaching a new phase. The first protons and neutrons, though few, begin to link. The nuclei of hydrogen, of helium, of lithium. These will become the first elements. But for now, the battlefield of matter and antimatter has cleared. And the victors, however few, have inherited the cosmos. You are built from those victors, from the 1 in a billion particles that remained after the storm. That number, that improbable survival, is why you exist.
3 minutes. That's all it took.
3 minutes to set the elemental stage for the entire universe. By now, the particle storm is calmed. The annihilations have ceased. The survivors, those precious few matter particles, remain. The universe is no longer an inferno. It's cooling, rapidly, but still unimaginably hot, about 1 billion degrees Kelvin. But in the cooling lies opportunity. For the first time, binding is possible. The energy of collisions no longer tears everything apart. Now, something new can begin. Fusion. This is the moment of nucleosynthesis, the moment when the raw fragments of the universe, protons and neutrons, begin to link together, not as loose particles, but as atoms' hearts. It begins with the simplest, most enduring of all, hydrogen. One lone proton. One solitary survivor of the great annihilation. Stable, unyielding, eternal. Every atom of hydrogen in your body, every H in H2O, every breath of air, every drop of blood can trace its lineage to this moment, to this very birth. But hydrogen is just the beginning. 2 particles bond, a proton and a neutron, to form deuterium, the heavy cousin of hydrogen. It's a delicate union, easily torn apart by the high-energy photons still flying through space. For a time, the universe plays a game of balance, creation versus destruction. But second by second, the photons weaken, the temperature drops, the bindings hold, and when they do, the assembly line begins. Deuterium fuses with other protons and neutrons, forming helium-3, then helium-4. 2 protons, 2 neutrons, an island of stability in a sea of chaos. Helium-4 becomes the second great element of the cosmos. By the end of this brief sacred window, just a few minutes long, the universe has manufactured the bulk of its primordial matter. About 75% hydrogen, about 25% helium, and traces, tiny hints, of lithium and beryllium. That's it. Just 3 elements. No oxygen, no carbon, no nitrogen, no iron. The ingredients for stars, planets, life, they do not exist yet. But what's born here, in this brief flicker of time, is the foundation, the canvas upon which the rest of the universe will be painted. And then, the window closes. As the universe continues to expand, it cools beyond the fusion threshold. The energy levels drop too low, the collisions become too gentle, the factories shut down. The elemental forging ends.
Big Bang nucleosynthesis is over. And it will never happen again. The cosmos will continue to make new elements in the hearts of stars, in the explosions of supernovae, in the crushing collisions of neutron stars. But this moment, this first forge, was unique. It made the lightest, most abundant elements in existence. And it did so in a heartbeat. The atoms you drink, the air you breathe, the hydrogen in the sun, the helium in birthday balloons, all began here, in this crucible of birth. As the universe cools below 100 million degrees, fusion ceases entirely. But what remains is not empty. The first atomic nuclei drift through space, carried on the expanding tide, still surrounded by a blinding fog of photons, still unpaired with electrons, still waiting to become atoms. But the building blocks are now real, fixed, permanent. The architecture of chemistry is in place. And all of it, every element that shapes the galaxies, the stars, the oceans and bones and blood, came from the ashes of annihilation, from the violent balance between energy and matter, from a handful of particles that refused to vanish. And the universe, though still young and still glowing, now carries the potential for everything. The materials of life have entered the stage. And all of this before the universe reached its 5th minute. For hundreds of thousands of years, the universe remained shrouded, not in darkness, but in blinding light. Because for all its brilliance, nothing could shine. The cosmos, now filled with hydrogen and helium nuclei, still boiled at over 3,000 degrees. Too hot for atoms, too wild for clarity. Photons, those messengers of light, were trapped, caught in an endless pinball game, bouncing from particle to particle, unable to move freely. The universe was opaque, like a fog made of fire. This was a universe without stars, without galaxies, without vision. A storm of light without a direction. But it was changing. Slowly, inevitably, the fire cooled. Space continued to stretch. Time continued to flow. And the temperature fell, tick by tick, until one day, around 380,000 years after the Big Bang, the fog lifted. This was the moment of recombination, the moment electrons finally slowed enough to be captured by atomic nuclei. The wild plasma transformed into neutral atoms. Hydrogen became hydrogen, helium became helium, and the light was free. For the first time, photons could travel great distances, no longer scattered by unbound electrons, no longer silenced. This was the birth of the first visible light, not from a star, not from a flame, but from the cosmos itself. A soft,
golden radiation, no longer blazing but glowing, poured out into space. This light, the oldest in existence, would become one of the most powerful relics of all time. It would stretch, it would fade, it would cool over billions of years, but it would never vanish. Today, we know it as the cosmic microwave background, the afterglow of creation, a whisper from the birth of the visible universe, a silent echo still humming all around us. In 1965, two radio engineers, Arno Penzias and Robert Wilson, heard a strange noise, a persistent hum that came from no specific direction and wouldn't go away. They tried everything, checked the instruments, even cleaned out pigeon droppings from the antenna, but the noise remained. What they had discovered was the whisper of the cosmos itself, the light from 13.8 billion years ago, still traveling through space.
They had found the afterglow of the Big Bang. That ancient light is everywhere. It washes over us every moment of every day. It fills every corner of space. It is the ultimate photograph, a snapshot of the universe just as it became transparent, a cosmic baby picture. And in it, we find the seeds of structure. Because this first light isn't perfectly smooth, it has tiny fluctuations, tiny ripples in temperature, imperceptible to the eye but crucial to the future. These ripples, fractions of a degree, reveal where matter was just a little more dense, where gravity could begin to work its magic, where stars and galaxies would one day form. In this glow, we see destiny in motion. The universe is no longer just a storm. It's a canvas. And now the paint can dry. But this moment, the release of light, is more than scientific. It is symbolic. This was the moment the universe became visible, the moment time could be seen, not just felt. Before this, no observer, even a hypothetical one, could have looked out and witnessed anything but chaos. Now, for the first time, the cosmos could be beheld. And so, in a sense, this is when the universe opened its eyes. From this moment, light has journeyed across the expanding fabric of reality. From that first great release to galaxies forming to the Earth's birth to us. Each photon a messenger from that ancient era, a traveler older than any star. Even now, as you listen to these words, that light is still arriving, still telling its story. It is the closest thing we have to time travel, to seeing the beginning. And though it fades, though it is cooled to just 2.7 Kelvin, barely above absolute zero, it speaks.
Fog has lifted. The universe is clear, silent, expanding, young. But it is not still. Far from it. In the aftermath of light's release, after photons burst free into space, the stage was set. The light told us something. That the infant universe wasn't uniform, not perfect, not smooth. It had wrinkles, tiny imperfections in its density, ripples in the very fabric of existence. 1 part in 100,000, so small they seemed meaningless. But these wrinkles changed everything. These faint fluctuations, these scars of quantum chaos from the first second, became the foundation of form. Where there was just a little more matter, gravity pulled just a little harder, and from those nearly invisible differences, structure began to form. There was no need for sound, no sculptor's hand, only a force, timeless, ruthless, always pulling, always shaping. Gravity, not as we casually know it, not the gentle fall of an apple or the curve of a planet's path. This was gravity in its primordial form, sweeping across light years, bending the cosmos, organizing chaos into architecture. Over millions of years,
Matter drifted and clumped. The universe became a cosmic web, a vast, sprawling network of filaments and voids. Galaxies would one day lie along those glowing threads, but for now, they were only gathering dust, literally. Clouds of gas, light as breath, drawn into knots of potential. Dark matter, still unseen, still unfelt, provided the scaffolding, an invisible skeleton guiding the dance. We don't know exactly what dark matter is, but we know what it does. It doesn't collide. It doesn't shine. It gravitates. It pulls normal matter along with it, acting like a quiet conductor behind the scenes, unseen yet essential.
Without it, the cosmos might have remained flat and uneventful. With it, the universe began to fold inward on itself, bit by bit. The first structures were not stars, not yet. They were halos, dense concentrations of matter forming in the deepest wells of gravity's sculpting hands. These were cosmic cradles, tens of millions of light years wide. They drew in gas, condensed it, and shaped it into the hearts of what would become galaxies. But still, they waited for something else, a spark. The universe was dark, lit only by the dim embers of the cosmic microwave background. No stars burned, no planets turned, just structure, potential, waiting in the night. This period, known to cosmologists as the Cosmic Dark Ages, lasted for hundreds of millions of years, an expanding, cooling, darkening universe, structure without light, form without flame. But even in this slumbering darkness, things were changing. The densest regions, like knots in a galactic rope, grew denser still. Gas pooled, gravity tightened, and in the bellies of these silent clouds, pressure began to rise. The first stars were coming. But before they could ignite, gravity had to finish its sculpture. This was the prelude, the blueprint, the quiet moment before the orchestra roars to life. Without this chapter, this age of structure, nothing would exist. No galaxies, no suns, no Earth, no you. The ripples in the microwave background were the fingerprints of fate, and gravity was the hand that followed them. It's humbling, isn't it, to think that everything we see, every galaxy, every nebula, every atom in your body, was born from a slight overdensity in an expanding fireball, from a wrinkle, a ripple, a bump, amplified by the oldest force of all. The universe was not designed, it wasn't planned, but from simplicity and structure, from randomness and gravity, emerged beauty. And though it took hundreds of millions of years for the first star to shine, its cradle was already waiting.
For hundreds of millions of years, the universe remained in darkness, not from the absence of matter, but from the absence of flame. Galaxies were forming in shadow, clouds of hydrogen gathered in silence. Gravity had prepared the world's greatest stage, but still the curtain had not risen, not yet. Then, somewhere in the vast silence, a threshold was crossed. A cloud of gas collapsed inward, tighter and tighter, until pressure ignited fire. And for the first time since time began, a star was born. It did not flicker softly. It roared. These were no ordinary stars. These were the first, the primordial giants, known to scientists as population 3 stars, and they were nothing like the stars we see today. Born in a universe untainted by heavier elements, these stars were forged purely from hydrogen and helium, simple, raw, ancient, without dust, without carbon, without iron, only the lightest, most elemental gases of creation. They were massive, hundreds of times the mass of our sun. Their gravity squeezed their cores to furious temperatures, and they burned fast and died young. A few million years, barely the blink of a cosmic eye.
but in their brief lives, they changed everything. For in their hearts, new elements were forged. Hydrogen fused into helium, helium into carbon, carbon into oxygen, nitrogen, iron. The raw ingredients of life and planets were being manufactured in real time. These were the universe's first alchemists. And when they could burn no longer, when their cores collapsed under the weight of their own making, they exploded. These titanic deaths, hypernovae, scattered their heavy elements across the darkness, seeding the cosmos with the building blocks of future stars, future worlds, future life. Each one was a funeral and a birth. From their ashes, newer stars would rise, smaller, longer-lived, and richer in elements. The universe was evolving, not just in structure, but in complexity. These first stars ended the cosmic dark ages. Their light pierced the fog of neutral hydrogen that still filled the space between galaxies. Their ultraviolet rays began to ionize the universe again, ripping electrons from atoms, making the cosmos transparent once more. This great transformation is known as the Epoch of Reionization. It didn't happen all at once. It spread like wildfires across an open plain, bubbles of light expanding from clusters of stars and primitive galaxies. And slowly, the night gave way to day. The first galaxies, small and chaotic, grew larger, merging, colliding, transforming. The scaffolding of dark matter became populated with light. Gravity.
1 billion years had passed since the Big Bang. But now the stars had ignited the cosmos. Their light carried information, their radiation sculpted the future. Their deaths seeded the ingredients for everything to come. And yet, even in this era of first fire, so much remained invisible. The first black holes, formed in the hearts of the most massive stars, now lurked silently. They began to grow, to feed, to bend space and time around them. Eventually, they would become the monstrous engines at the cores of galaxies, quasars that outshine trillions of suns. But at this moment, they were seeds, waiting. It's easy to forget that every star we see today is a descendant of these first giants. Their ashes became our atoms. Their light became our dawn. When you look up at the stars, you are witnessing the echo of that first rebellion against darkness. You are the child of an ancient explosion, the product of a fire that once burned in a star that no longer exists. A star born in a universe that had just opened its eyes. The first stars lit the path, and now, billions of years later, we walk in their light.
1 billion years have passed since time began. The silence is gone. The darkness has retreated. The stars, billions of them, have risen. And now, from the scattered sparks of light, galaxies awaken. These aren't mere collections of stars. They are cities of fire, beacons across a vast and growing cosmos. Each one a monument to gravity, time, and ancient ignition. Some are serene spirals. Others, chaotic and wild, merge in cosmic collisions that send shockwaves across the universe. Every crash is a symphony of destruction and rebirth. Stars are torn apart. New ones are born. Black holes swell at their centers like sleeping gods. From these great unions emerge the structures we see today, grand spirals like our Milky Way, and the immense elliptical galaxies that rule clusters of galaxies. The universe is no longer just expanding, it is thriving. Every element in your body, every atom of oxygen, iron, calcium, was forged in the belly of a star. You are made of stardust, not metaphorically, literally. Galaxies become the gardens of chemistry, where matter is recycled in endless loops. Stars die, supernovae explode, debris coalesces, new stars emerge. And in the swirling arms of galaxies, around humble stars, planets begin to form. Among them, one world bathed in liquid water and protected by a fragile atmosphere would come to bear witness to the universe itself. We call it home, but in the grand scale, it is just one thread in a vast cosmic tapestry. This tapestry stretches across 93 billion light years and counting, a trillion galaxies, a septillion stars. And yet, it all began with a spark, a single moment, a first second, a fire birthed from nothing. We have come a long way, from the searing chaos of the first second to the quiet complexity of now. The universe did not unfold as a story told to us. It is a story we discovered, layer by layer, light by light. We looked into the sky, and we saw time. We mapped the cosmic microwave background, listened to the whisper of gravitational waves, captured the light of galaxies so far away they existed before our sun was born. And we understood what was one.
If this journey through time and space sparked wonder in you, if the origins of the universe stirred something ancient and curious in your soul, then don't let the light fade. There is so much more to uncover, from the birth of black holes to the future fate of our universe. So subscribe, share, and stay curious. Because this isn't the end of the story. It's only the beginning of everything.